Okay, this is lecture 19. Due to my personal issue, lecture 19 is recorded. Instead of continuing our discussion on the Shapet-Kummer scheme, in this lecture, I just wanted to give some comments on the term project proposals. We have 5 students and 4 students submitted their proposals for the term project. The topics are distributed and interesting. However, in many cases, it seems to be difficult to achieve the goal within the limited time. So, for some cases, I would like to suggest a simpler task to each proposal. The first proposal is about the time domain thermoreflectance. The heat diffusion equation is solved under the one-dimensional approximation. In my opinion, solve the heat diffusion equation in the time domain is not that difficult. The sample seems to be multilayered. Which boundary condition will be used at the layer interface? Although pump and probe are time-dependent signals, it is not clear whether they are really included in the simulation or not. More detailed information seems to be needed. Anyway, since the topic is closely related with the student's own research, it is a nice try. One student suggested the molybdenum disulfide simulation. From the DFT simulation, we can obtain the band structure of MS2. Then, important material parameters such as the band gap and the intrinsic carrier density can be obtained. Considering a two-dimensional material sounds great. Although we have not covered such materials in this course, it is trendy and interesting. However, when we say the TCAD simulation, it does not consider the atomistic structure of a given material. There are too many steps between the band structure and the TCAD device simulation. Actually, the complete workflow sketched in this proposal seems to be unavailable right now. In my opinion, first of all, you must search and read reference papers for the device simulation of two-dimensional materials. Then we can make another separate session for discussion. Another proposal was on the DRAM simulation. Since the DRAM cell is made of a transistor and a capacitor, we must analyze the MOSFET, which is at least a two-dimensional device. However, up to now, our lecture progress does not cover any two-dimensional device. Of course, in principle, we considered the box method. However, its implementation is not that easy. Moreover, the DRAM is written and read. We must analyze the transient simulation with the mixed mode. In my opinion, we can try one of two simplified versions. The first one is to simulate just DC characteristics of a MOSFET. I think that it's not an easy task to beginners. Another one is to simulate a simpler device and a capacitor in the time domain. For example, a rectifier can be a good example, good application, since we will learn how to perform the transient simulation for a PN diode. It would not be very difficult to implement. The final proposal is about the diffusion simulation. Impacts of the doping concentration and the diffusion time will be studied for several dopants. Yes, we considered the diffusion simulation in this semester. Therefore, the proposal seems to be reasonable. My comments are following. There are many models for the diffusion simulation. It is not clear which model will be adopted in the term project. For the most part, we must implement it in the two-dimensional domain. Also, realistic initial dopant profiles are needed. Most importantly, how can you verify your simulation result? For that purpose, extensive literature survey seems to be mandatory. Okay, up to now, I have briefly covered the term project proposals. Since you must meet the deadline, don't be too much ambitious. Please set a reasonable plan and report your progress. Thank you.